When a celestial body's Greenwich hour angle, or GHA, and declination are determined, its geographic position, or subpoint on Earth, is known. Obviously, if from a measurement you find the celestial body to be directly overhead at your zenith, you would know you were at the GP of the body, and your latitude and longitude would be the same as the body's celestial coordinates. But the chances of this happening are very rare. Usually, you are some distance away from the GP of the celestial body. When this situation exists, you are only able to determine a line of position. To determine this line of position, we utilize the horizon system. When we extend a line from your position in one direction to your zenith, and in the other direction through the center of the Earth, out the other side, and on out to the celestial sphere again, we have what is called a zenith-nadir axis. A great circle plane perpendicular to the zenith-nadir axis is called the celestial horizon. In effect, we are creating a new reference system with your position at the center. Great circles containing the zenith-nadir axis are called vertical circles. Now we must determine where the celestial body is on the vertical circle. To do this, you must recognize that the distances of space are so great that light from a celestial body arrives at the Earth in a narrow band of rays that can be considered parallel. From your geometry, you remember that a straight line cuts across parallel planes at the same angle. So an angle observed at the surface of the Earth is really the same as that at the center. Suppose the angle is 0 degrees. The celestial body will appear to be on the celestial horizon. This is just a way of saying that the thickness of the Earth can be disregarded in celestial computations. The measured angle of a celestial body from the celestial horizon is called altitude. It is indicated by the letter H. Altitude, when computed, is called HC. It is called HS when it is sighted through a sextant, and it is called HO when the sextant reading is corrected for instrument and observation error. It is easy to confuse altitude with declination, but remember, altitude is measured from your celestial horizon. Declination is measured from the celestial equator. For example, the declination of Polaris is approximately 90 degrees, but its altitude varies depending on your location on Earth. It stands to reason that the angle of altitude will always be less than 90 degrees unless the celestial body is directly overhead. The farther you move away from the GP of a body, the smaller the angle of altitude. The closer you come, the larger the angle. The difference between 90 degrees and the observed altitude of a celestial body is called co-altitude, or zenith distance. This is an important angle to remember when you begin to use celestial navigation to plot a line of position, because zenith distance can also be expressed in nautical miles on the surface of the Earth. Let's say you have obtained a sextant observation of 70 degrees on a star. You can see that a 70-degree measurement can be made from any number of points. You immediately know that you are someplace on this circle, called a circle of equal altitude. This is the first step toward determining a line of position. To find out how far away you are in nautical miles, merely compute the zenith distance. 90 degrees minus 70 degrees observed altitude equals 20 degrees. Therefore, 20 degrees arc distance separates your position on Earth from the GP of the star. Since 1 degree equals 60 nautical miles, you are 1,200 miles from the GP of the star. To find your precise position on this circle of equal altitude, you must take an observation of another body to determine a fixed position. 2 intersections will be noted, but only one will be near your DR position. A third observation will confirm your actual position. So far, we have reviewed with you the terrestrial grid system and the celestial grid system. They are related by your zenith and the geographic position of an observed celestial body. The GHA and declination of a celestial body can be translated into latitude and longitude of its GP on Earth. GHA and declination of the Sun, the Moon, and the planets Venus, Jupiter, and Saturn are available in the Air Almanac for given dates and times. The GHA of Aries is also given, along with the sidereal hour angles for the 57 stars. We have also discussed the horizon system and how it is used to locate a line of position from the geographic position of an observed celestial body. When you note the altitude, you know you are somewhere on a circle of equal altitude around the GP of the observed body. The technique of actually plotting a line of position depends on the observed altitude of the celestial body. If it is 85 degrees or more, the zenith distance formula shows that you are within 300 nautical miles of the GP, and you can actually plot the circle of equal altitude on the navigator's chart. But if the altitude is less than 85 degrees, and it usually will be, you would need a chart too large to fit in your aircraft. So you must use a different technique. It is called the intercept method, and it will be discussed in part 3 of this series.